welcome to another episode of Rustacean Station. I'm your host, Alan Wyma. Today, I'm with Matt Butcher. Did I say that right? I always feel like I say that wrong. Butcher, because I think about Butcher, maybe.
Butcher, you got it right.
Right,
Yep.
Matt Butcher. He's the CEO and founder of Fermyon. Welcome, Matt. How are you?
Great. Thanks for having me today.
Yeah, it's good to have you on, right? Because you have such a wide and interesting background. I mean, you had your publicist, or I don't know how you say that, or she went out and found us and wanted to bring you on the show. And I'm like, oh, wow, this is the first experience I've ever had where somebody else is scheduling for somebody. But it's like, okay, I've never heard of this guy directly. But the work you've done in the past is something that I think we probably all have heard of, as we discussed over a call last week. Maybe you can give a kind of a quick elevator pitch about who you are so that we can start to know who you are.
Sure. Yeah. So I've been working in open source for pretty much my entire career, which is now somewhere over 20 years. I stopped counting at 20, right? And so most of that time, I've been doing open source software development of one variety or another. For a long time, I did content management system work, particularly in Java and then PHP worlds. Then at some point, switched tracks into cloud. And it really kind of changed my view of where the industry could go. I was happy to say that I was on the right track there. And, that led us all the way up to where we are now, starting a company about a year ago and really kind of building a new kind of cloud service. So, yeah, it's been a kind of varied experience. I think this weekend was the first time I'd written PHP in 10 years. I found a VMware has a PHP WebAssembly implementation, and everything we do is WebAssembly. And I saw that and I'm like, oh, I got to try this. And then I had all these like flashbacks to, life in the days of yore and the kinds of things we were doing, back in the Drupal world and the WordPress world. And it was kind of a fun trip down memory lane to do that. But this is a good opportunity to reflect on how much things have changed over my career.
Okay. Actually, sorry, I want to kind of go back about this term cloud, right? Because cloud is such a marketing term. You know what I mean? Like, I just remember a long time ago, we had, not VPCs, we had called them VMs. And I remember just spinning up a VM and it was just normal. And then like all of a sudden this word cloud came out and I felt like, aren't I already doing cloud stuff before cloud really became a word and a thing? Like if I spin up a VM, doesn't that mean I'm in the cloud?
Yeah, this gives me a chance to kind of zoom back into that area of transition from like the CMS-y world into the cloud world, right? I did content management systems. We would deploy to hardware, right? We had a data center and there was an operations team there and we would build our CMS platform. I worked for part of New York Times's organization called Consumer Research, and they had a huge Drupal platform, and we had like 8 servers, and we had package up our whole Drupal installation and tar it up and ship it over to the operations team, and then sit online as they released it out to the production servers, which all sat in a data center about 2 floors under where I sat at my desk, right? And even at that time, virtual machines were not particularly new. I think I had like Parallels on my Mac so that I could run the 2 Windows apps I needed to fill out my expense report and my timesheet or whatever. But we weren't thinking about virtual machines really as being anything particularly special, just sort of a way to run a couple of applications in an unfamiliar environment. I left there and a few years later went to HP. And I went to HP to build a CMS system for them for this new thing they were building. They were building this thing they called HP Cloud. And I was like, yeah, whatever, I'm there to do the content management system. I'm a Drupal developer. I'll run the websites. And, the word cloud had like no meaning to me whatsoever, right? It just meant somebody's servery things somewhere. But once I got in there and started playing around with the technology they were building, it was like one of those kind of light bulb goes on sort of moments that it didn't just make me go, oh, okay, I get it. So it's like this. It's one of those things where I hit an experience and went, that changed the direction of my career, right? I don't want to do CMS anymore. That's boring. I want to do this cloud thing. And I think kind of that crucial realization was the moment when it dawned on me that cloud was changing the fundamental relationship between the way we looked at a piece of hardware and the way we looked at an operating system. So up until that point, I largely thought of operating systems as sort of a one-to-one, I've got one operating system on my local machine. That's my main operating system. And that's the thing I use. And yeah, I might use Parallels to run a couple applications. But for the most part, I was thinking of this in a one-to-one kind of way. And what really got me excited about cloud was going, oh, no, it's like a one-to-many relationship. And there are tons of operating systems running out there in these gigantic, 6U servers out there in an HP data center somewhere. And all I'm doing is packaging my operating system with the tools that I want and the applications I want. And I'm renting somebody else's hardware. I'm paying somebody else's utility bill to run this, big system. And that was kind of the first experience I had where it clicked for me. Oh, okay. So at the end of the day, cloud is just changing around that way we do operations so that I'm just essentially renting or leasing somebody else's hardware and, to a great extent, somebody else's operations team as well, right? I mean, we still have platform engineering and DevOps, but the things that we care about as a platform engineer are markedly different from back in the day when it was like, oh, a card went out in the system. All right, now I've got to shift load, replace that card, and maybe update the operating system while it's down. That kind of stuff is sort of relegated to a different team that I never see and never know anything about. I have no idea what the physical hardware is that I'm executing any of my virtual machines on anymore. And so it really is it's a different world than what I was used to back when I used to do these things with sort of physical data centers that we managed.
Yeah, now that I think about it, actually, there's only one company that I worked at where we didn't necessarily have a cloud. Like it was a finance company, a finance vendor, and they literally had rented. Actually, I don't know I guess you can call it semi-cloud. I don't know. They rented out like a space in a data center, but they brought in their own machines. So I guess only that company brought in like the internet or whatever, and they had it in a cage with a lock and key and whenever something really went bad, they had to drive from like New York City down to like New Jersey and literally like start physically working with it. It's quite interesting. And we didn't have VMs or anything like that. Like just you would SSH into this massive server and you would be doing everything. It was a very weird situation. I just thought about that right now. Oh yeah, actually we did have, that was not like the first company, I think, and maybe the only one I worked at where we didn't have an actual VM/cloud kind of thing happening.
Yeah, we rented a data center that we called the giant air hockey rink because, it had the floor tiles that would recirculate the air up through there. And, whenever a hard drive went out or a network card went bad, somebody would have to get in the car and drive an hour or two from our office to get to the data center, hopefully with the right set of hardware, and go replace it. So cloud, yeah, man. Some people might be dismissive of cloud as like some kind of marketing slang, but I tell you, it sure beats driving somewhere at 2 a.m. to replace a NIC. So
yeah, I think, well, nowadays it's different, but I think in the maybe mid 2010s, at least from what I remember, like all the market people were like, oh yeah, let's tell everybody we're in the cloud. We're in the cloud, right? Like that was the part that bugged me, was like, yeah, of course. Like we're like 3 people in like a 200 square foot office. Like, well, where to put a data center? Like, do you really need to market this to people? Like, but damn, it was like cloud was the word. And if you didn't say, like, I guess maybe there was quite a few investors who, if you didn't say you're in the cloud, they may think you're not good enough to invest in or something, which kind of makes less sense, I guess. I don't know. In any case, like, I just remember that was like, you had to say, it was part of your bullet points, is that we're in the cloud. Oh, you're in the cloud? Here's a check. Like that's what I felt like was coming from their side.
Yeah, I feel like I've lived through a couple of those, right? The first one was websites, right? Like, do you have a website? And then, that was late 90s for me. That was when I was young and just getting started. And then it was, do you have a CMS? And then do you have this? And then it was, do you have a cloud? And I don't know, it seems that there's a certain trendiness. We like to think we're somewhat resilient to trends, but actually we're not at all, right? We like to stick with whatever the latest trends are and put enough enthusiasm about it that I think we generate a lot of peer pressure in that regard, right? We make people feel like if you don't say you're in the cloud, then you're in the out club. What is the term Jeffrey Moore used? You're a laggard, right? You're a technological laggard. You're the last one.
Yeah. Oh, you mean that graph, right? Where you're either
yeah, that big graph. It's like those early adopters and the leading edge and all that, and then the tech laggards are the last ones.
Yeah, I know what you mean. Yeah, it's been a while since I looked at that one. So somebody was just showing off that one last week on a video I watched. But coming back, right? So that's interesting that you're kind of on the beginning of this, and you basically saw that everything was going this way once you joined HP and working on HP Cloud, right? And you're like, okay, this is kind of where I want to be because this is where things are going to go, right?
Yeah, and I think at that point, HP was early enough into the cloud game, and they were big contributors to OpenStack, which is an open source stack upon which you can, manage virtual machines and object storage. And we really had the goal in mind that we would be in the top 3, that we would catch up to Amazon and be right up there at the very top. And I think it was early enough in the whole cloud thing that we had a chance, right? I mean, it wasn't completely irrational to think that we could have caught up. But over time, we got out innovated on some things and things changed around enough internally that it got harder to get our job done. And I think we fell behind. I shouldn't say I think we fell. We objectively fell behind, right? HP is not one of the big clouds right now. And it was a tough one. By that point, I was working in platform as a service. So the idea was we were going to build a sort of self-service, Heroku style deployment engine. And this was when Heroku was very new, where people could deploy their applications into that environment, where developers could deploy their applications. And I remember kind of realizing, oh, we're falling farther and farther behind. Azure's now up there and Google's now up there and then Oracle's now up there. There's fewer and fewer top spots for us to be able to claim. So when I left HP, I left kind of feeling kind of despairing, right? Like, oh, well, this cloud thing was cool, and I thought I had an opportunity here, but I guess not. So I went from cloud to IoT. I went from the giant data center back to the embedded world. But really, I did that to kind of run cloud for a startup company in Boulder called Revolve. And we were building consumer-based, a little hub that sat in your house and it could control 9 different classes of IoT devices, including, everything from like Hue light bulbs and Sonos speakers to Insteon light switches and Lutron light switches. And it was really fun. We built some really cool technology. But, when you're out of your house, if you want to control the stuff in your house, then you need a cloud service to do that. And so I took on the head of cloud role there and built out the whole cloud side of Revolve. And so it was like I came in despairing, I don't know what's going to happen in the cloud, and then really got going again and got re-energized. And containers were brand new at that point. Docker had just sort of changed their name and started talking about Docker containers and trying to remember what their name was before Docker. It was like, I want to say .cloud, but that doesn't sound right. But, it was a very interesting time to be playing around with new cloud features. And so Google came and bought that company. And so I spent a little while at Google. Google was not totally my thing. I was like, really wanted to do the startup life. And so I left Google and went to another startup that was literally like a block away from the startup that Google had bought. So just like kind of walk down the street. And that one was a company called Deus that was building a platform as a service based on containers. So I started with virtual machines and I went from virtual machines at HP Cloud over to kind of the container ecosystem. And once again, got that chance to kind of build the platform as a service, developer self-service thing. Deus's stated goal was to build an open source competitor to Heroku. That was what we wanted to do. And so it was like totally in my wheelhouse. I was really excited. And we came in there and for a while was the architect of that one. And then along came this technology out of Google. Nobody knew how to pronounce when it first came out, right? We're all like, But Kubernetes, right around 1.0, we got really excited about it. And we looked at it and said, oh, well, this is a technology that's going to really change how we can do this PaaS because we can bundle up all the apps and containers, which we were planning on doing. And then we can schedule them out into these massive clusters and let Kubernetes do all that scheduling. And at this time, Kubernetes had like 5 different kinds. It was not a sophisticated platform at that point. It was very easy to understand and easy to grok. So we got re-platforming all of this stuff on Kubernetes, and I was just, bought in hook, line, and sinker. But one of the hard parts was we couldn't really figure out how to install our platform into Kubernetes because Kubernetes, you had to write a bunch of YAML files, and then you had to kind of hand load these YAML files one at a time into Kubernetes. And even while it was stateless, trying to get all the YAML files in at the right time and get everything kind of stood up was a pain, and you had to go hand edit everything. And so we started talking about it. We had an offsite, and we were going to do a hackathon project. And there was like a $75 gift card for the people who won the hackathon. It was like, oh, this is going to be awesome. Our 3-person team is going to win the Deus hackathon. What should we build? Let's build a package manager for Kubernetes. And we can build like a little YAML file manager, and we can describe our application in it. And so we built this little tool. It was called Kate's Place because K8S, Kate's was the abbreviation for Kubernetes. And we thought Kate's Place sounded like a coffee shop. So we had this little kind of coffee shop theme. It was based sort of loosely on NPM. So we had 2 days to build this thing for the hackathon, 2 evenings. And my team was a little gregarious, and we, bailed on all the team drinking events and stuff like that and spent all of our time hacking away at this thing. And we finished it. And we won the $75 gift card. And it was awesome. We split it 3 ways. I bought a bag of coffee and a mug or something like that with my $25. Well, the day after the hackathon, kind of back in the office, hacking away at the usual code, and my phone rings. And it's the CEO and the CTO of Deus. And I'm like, uh-oh, what did I do? And they're like, the hackathon project you did, the Kate's Place thing, that was really cool. I mean, we can kind of understand how Kubernetes would need a package manager, but we really don't like the name. So, come up with a new name and then create a team that'll do this kind of, Kubernetes package manager thing. So we said, okay. So I called Jack, one of the other of the 3 guys who were working together on the hackathon project. Jack was one of the others. And I said, so they like our idea, but they want a different name. Kubernetes means pilot in Greek, or like ship's captain in Greek. So we thought, all right, we'll have to find something with the kind of nautical thing. So we got a nautical dictionary. And, I don't know if you've ever spent any time with a nautical dictionary, but, names like poop deck are not really going to stick with your typical customer audience. So we're just like reading random things back and forth. Starboard, no. Mast, no. And Jack's telling us that we said it simultaneously. Mine is that he said it first. Is like helm, suggested helm is the name. And I'm like, oh, helm, I like that name. So we kind of went with that. We built the package manager for Kubernetes called Helm, which surprisingly got a lot of traction. And I think we're up to about 2 million downloads a month or something on Helm. That was really what got me sucked out of the sort of bare container world and into this orchestration layer. Not too long after that, the guy who created Kubernetes, Brendan Burns, left from Google, where he had worked, and joined Microsoft. And at Microsoft, they kind of gave him carte blanche to build the best Kubernetes team he could build. And so he acquired Deus and split us into 2 different teams. And one team went and built the Azure Kubernetes service offering, which is this really awesome managed Kubernetes thing. And the other team, my team, he basically said, look, yeah, you've done some interesting stuff. Why don't you just do like container R&D stuff, listen to people, figure out what they want, and kind of build things. And also Microsoft has a bad reputation in open source. So, do your best to repair that along the way. And so for about 5 years, my team at Deus kept growing at Microsoft and producing more and more of these open source tools. We started with Helm and then produced, Draft and Brigade and CNAB and OAM and all, just kind of this litany of open source tools that were all really part of the Kubernetes ecosystem. And that was really when we started getting into Rust then too. As y'all know, Kubernetes is built primarily in Go. Go is a great language for a number of things, but as complexity of an application grows, Go code, in my opinion, gets very difficult to manage. And the lack of a really great generic system is part of it, is just sort of the simplicity of the language, which doesn't always necessarily lead toward the most elegant designs. So we started building things in Rust. I think the first project we built in Rust was just kind of an open source application model kind of thing, but it was really more to kind of cut our teeth on the language. But, along the way, we had started accumulating a list of things we couldn't figure out how to do well with containers. And really for us, the biggest one was that we wanted to figure out how to get containers to shut down and start up really, really fast. If you think about the way that we tend to run applications, particularly in large scale cluster environments like that, you deploy your microservice, right? It's like a 5 meg binary or a 10 meg binary or something like that. But you deploy it and you deploy 3 of them and you deploy them kind of out into this cluster. Maybe you deploy 5 or 10 or whatever, enough to scale up to the load you need it to be able to handle at peak. So then you got a whole bunch of things that are just sitting there waiting to be helpful at peak, but are largely sitting idle the rest of the time. So we thought, all right, what if we can figure out a way to shut those containers down when they're not being used and then start them up again right when requests come in, so that you can save on the electricity bill, so that you can cut your cloud spend, right? But containers take too long to shut down and start up. Well, in particular, they take too long to start up. So we had tried several things. The name we gave to this problem was the scale to zero problem. You want to be able to scale all the way down to zero when there's no load coming in, and all the way back up to whatever your max is whenever there's a lot of load. Couldn't figure out how to do it with containers. So we're kind of sitting around going, well, there's got to be another way to solve this. So we went back to virtual machines and said, maybe we could solve this with virtual machines instead of containers, because we got 2 kinds of compute, virtual machines and containers. Couldn't solve it with virtual machines. And then one of those sort of, again, another kind of light bulb moment flickers on. And we're going, well, wait a minute. Why do we think there are only two kinds of compute? We got virtual machines, we got containers. Maybe there's a third thing somewhere over here that we just haven't noticed yet. So we started looking around and saying, what would the third wave of cloud computing look like? What would this third kind of runtime be? And the surprising result of our investigation was WebAssembly, which sits in the web browser, actually a really good model for the cloud. And the reason why is because the features you need in order to have a really good target like this for the browser were exactly the list of things that we were looking for in the cloud. So WebAssembly, at the end of the day, you'll hear people, sing the praises of WebAssembly about all that it is. At the end of the day, it's really just an executable format, right? That you can compile different languages to, that's kind of platform neutral, and a specification for how the runtime ought to work. And the specification says, okay, now, and here's the crucial part about WebAssembly. Now, the guest code, the code that's running inside of the language virtual machine, should not be trusted, right? When you think about the way you write Java or you write .NET, both of which are virtual machine languages, you trust that the binary you're running should have access to the file system and should be able to read environment variables. And by default, that's your disposition toward the application. WebAssembly is going to run in the web browser. And you don't want to assume when you're running your web browser that you should trust any of the code kind of running in there, right? You want to assume nothing, right? You want to be like, yeah, there's no way I'm going to let my box get rooted by somebody else's code running in my browser. So the security model fit perfectly for the browser. So WebAssembly is really a very simple idea. And I think you hear a lot of people kind of making a big deal about, WebAssembly is going to solve all the world's problems. But really, WebAssembly is, at the end of the day, a very straightforward technology. It's two things. It's a description of a binary format, and it's a description of the runtime that executes that binary format. And as soon as I say this, I mean, the things you should be thinking of are like Java and .NET, right? Two different language ecosystems that follow that same kind of pattern. So in Java, you write your code, you compile it to Java bytecodes, and then when you execute it, it executes on a Java virtual machine, a language virtual machine. And WebAssembly is that same kind of dual model, right? Except with one critical difference there. In Java and .NET, the default disposition of the runtime is to trust the binary that it's executing. So when I write my Java code, I can write code that opens a file and reads the contents and writes them back down to the file, right? I have file system access through there. Now, WebAssembly is built for the web browser. And you don't really want to open a web page and know that whatever code loads on that website is going to be able to open a file and write to it and read to it and whatnot, right? You really want to keep the sandbox very, very strict as far as what that code can do. So WebAssembly was designed with an even stricter sandbox than what you get for JavaScript. Really, it can't do anything other than the raw computation. And then you can kind of inject or expose to it JavaScript functions that it can call back and forth for the browser. This is the browser model again. The way we use it is quite a bit different, but this was the browser model it was built for. So by default, WebAssembly's runtime does not trust the executable. We talk about it and say the host does not trust the guest. Now, this particular model is perfect for the cloud because that is, in fact, even going back to a couple minutes ago when we were talking about what the cloud is, right? It's me renting somebody else's resources to execute my stuff. And for me, I want to know that my stuff is going to run there, right? For them, they want to know that even if I'm a bad actor, even if I'm up to something evil, I can't take over their systems and then access their other customer data or root their hypervisor or anything like that. So that model of the host not trusting the guest is basically at the root of all the cloud technologies, right? Including containers and virtual machines. And so when we found that WebAssembly really had this particular feature to it and had all these other things that we were looking for, ultra fast startup time, cross OS, cross architecture, all these other features, we said, okay, this might be the candidate we're looking for this kind of third kind of cloud computing technology that we would be able to use to do these hyper-fast scaling up and down kinds of things. So we spent some time developing that idea out. COVID hit, we were all kind of locked in our houses, either bored out of our minds or depressed. And we said, all right, let's just do fun stuff with WebAssembly. We'll spend a year doing fun stuff with WebAssembly. Well, we still did our day job too, but this was kind of our way of venting. It was like Thursdays and Fridays we would spend working on WebAssembly stuff. And we got WebAssembly running inside of Kubernetes. We built this project called Krustlet. that was a virtual kubelet that executed WebAssembly modules within Kubernetes side by side with containers. And we were proud of it, but we were also kind of frustrated because as much as we loved Kubernetes, and again, I mean, this is a team of Kubernetes engineers that had done a whole bunch of core Kubernetes projects. And we were frustrated with Kubernetes because it makes so many assumptions that the thing that it's executing is a container that we just found that the process of building Krustlet was the process of building an increasingly elaborate set of lies to convince Kubernetes that it was running a container when in fact it was running a WebAssembly module. So we hit that kind of hard spot where we went, okay, we're going to have to leave the Kubernetes ecosystem if we really want to do this right. So we started experimenting with other things. Ultimately, we were in the Kubernetes team at Microsoft, and it became clear that we were not going to be able to keep doing this work in the Kubernetes team in Microsoft. And at that point, we said, all right, we feel like we have a good enough idea that we could go do a startup. And so 10 of the engineers in that team, we all picked up on the same day, resigned from Microsoft, and a couple weeks later started a new company called Fermyon with the express goal of figuring out how to build this kind of third wave of cloud computing based on WebAssembly. So that was November 1st of last year. And then from there, we set out to build three things. It was really important to us as a bunch of open source developers that we do as much in open source world as we possibly could. And also important to us as software developers that we would sidestep the really big issue we had with Kubernetes, which is that it was not developer friendly. It was a very difficult platform for an average software developer to figure out how to use, right? And part of the issue with Kubernetes abstractions is they kind of leak all the way up into the code, and the developer really kind of has to understand what they're doing and build the containers accordingly. And it just kind of, there was no easy way to build them, to build those kinds of applications. You just kind of had to slog through a big learning curve. So we said, all right, if we're going to do this again, we're going to do this in a very developer-friendly way. Now, most of the WebAssembly ecosystem is broken into two kind of stacks, right? There's the V8 stack that's heavy on, the original V8 source code, which I think is all C++, and then a lot of JavaScript shimming on there. And that's the one that a lot of the browsers use. But there's another ecosystem. WebAssembly came out of Mozilla, and Rust came out of Mozilla. And so unsurprisingly, the same developers who worked on Rust worked on WebAssembly, and there's an unbelievably strong WebAssembly ecosystem in the Rust community. I mean, I honestly think that at this point, the Rust ecosystem has more mature WebAssembly tools than the browser ecosystems tend to. And part of that is just because they're a little more collaborative than, say, the Edge, Chrome, and Safari and Mozilla set, who each kind of maintain their own platforms. So as we got going at Fermyon, we're writing everything in Rust, except for our front-end application, which is written in .NET. And we really that decision made it possible for us to begin with this really, really high-grade, production-ready set of WebAssembly tools that we could build a cloud platform on top of. So we started with a developer tool. The first tool is called Spin. And we like to talk about it sort of as either like the Docker CLI for WebAssembly or like the Swiss Army knife of getting going with WebAssembly, right? You can basically type in spin new and choose your language and name your project. So spin new Rust, foo will create a new Rust WebAssembly application called foo. And then you can do spin build and it'll build it into a WebAssembly module, and spin up and it'll start up a local instance of a WebAssembly server that you can then execute. And we wanted to build tools like that were just so easy that you could use them in VS Code, you could use them in Vim, you could use them in Emacs, whatever you really kind of wanted to do. It was really only a matter of learning 3 or 4 new commands, all of which should be fairly self-evident once you get going, right? And that was our first tool, Spin. Second tool we created after that was called Fermyon Platform, and that was our cloud reference platform. It's largely a Terraform installer that installed all the pieces you would need to run a WebAssembly service. And then you could take Spin and you could type spin deploy with your, brand new Spin app, and it would push it out to your platform and you'd be able to run it. And the last one was in October, just a couple months ago, at the end of October, we released Fermyon Cloud, which is our hosted version of our own Fermyon platform. And the intention there was to make it so easy to use that you don't even need to stand up your own infrastructure. You really can do a 3 command, spin new, spin build, spin deploy, and have it go out and have it running on somebody else's hardware. Because again, that's the virtue of the cloud. You run your stuff on somebody else's hardware and they take care of the hard part. So that's really where we are at this point. We launched that a little while ago. And now it's just a matter of building out all the features we have in our minds for making WebAssembly kind of the next wave of cloud computing.
Oh, that's a long history. So many questions in between.
Sorry, yeah.
Yeah, no, it's fine. It's good to hear like kind of like what's going on. Something I did want to talk about before that I think a lot of people don't know, at least of course when we talked last week, I didn't know. Maybe I'm not the most into all the stuff, but we talked about Krustlet, right? I think, and maybe I'm wrong, but I think that most people think that Krustlet is still around, but that's not quite true. So there's kind of a couple of things I wanted to go over for that one. One is what happened to Krustlet. I think we talked about specifically it's lacking in some core pieces. So that's why you kind of like archived it to a certain extent. Well, didn't actually archive it on GitHub, I think, but you basically said you're not working on it. And why something else would be better for that. And actually, I think you said you're working on something else, right?
Yeah. So Krustlet was really our first, well, it was probably our third or fourth experiment, but our first one that saw the light of day, first experiment on executing WebAssembly inside of Kubernetes. And the idea of it was to write a virtual kubelet. So essentially a thing that's running in your cluster that's acting like an extra node, even though in fact it's virtual, and allow only WebAssembly jobs to be scheduled on that node. So you deploy a pod that declares it's got a container, it's going to run in your regular pool of kubelets, but you deploy a pod that has a taint on for WebAssembly and it gets deployed onto your virtual kubelet Krustlet. So that in and of itself is a topic for another time, right? But the idea there was that we would build a runtime there that would look like the rest of the Kubernetes control plane. You could schedule jobs or deployments or whatever. And if they had WebAssembly modules, they would be executed on the kubelet. The core idea was not bad. The core idea worked fairly well. There is another project called Virtual Kubelet that does this with a number of different other backend runtimes, including virtual machines. But there were a few things that got very frustrating very fast for us. And one of those was, again, we were kind of continually pretending that the WebAssembly was a container, right? Because Kubernetes is completely based around the container as a primitive. And yet a WebAssembly module executes differently than a container. We can start and run to completion and stop a WebAssembly module in a matter of milliseconds. But we were frustrated because the health check for Kubernetes didn't get triggered until 6 seconds in, because the health check was assuming that it would take at least 6 seconds to bootstrap a container. And so while we could run all these successful jobs to completion, the dashboard just showed red all across because it thought none of them had ever started, because the health check didn't even fire off until they'd started up and run to completion and shut down. So there were things like that where it was like, this is just frustrating. We're trying to make it look like the network stack is the same as a container. We're trying to make it look like storage works the same as a container. We're trying to make it look like health check looks the same as a container. And at some point we just went, okay, we wrote a code base that's 100,000 lines of code. And largely it's all to make a WebAssembly module look like a container. So we stopped using Kubernetes and we tried a couple of other things. And we ended up trying HashiCorp's Nomad scheduler, which is really more a process scheduler than a container scheduler. And with no code, we were able to get Nomad scheduling WebAssembly more efficiently than what we could do with Krustlet in Kubernetes. And we went, okay, all right. So it's not so much, we're just mismatching technologies, right? So we really need to stick with something that matches really well. So as Fermyon got started, we switched our scheduler to Nomad. Still to this day, we're running Nomad. We can schedule hundreds and hundreds of WebAssembly applications per node inside of a Nomad cluster. It's great. Love it. When we left Microsoft, not everybody left and went to Fermyon. There were some people who stayed and continued doing WebAssembly work, and we work quite a bit with them now. But they too kind of arrived at the conclusion that Krustlet was not the right answer to the problem, but they decided to take a different approach to it. So they built a tool called RunWASI, RUNWASI. WASI stands for WebAssembly System Interface and is essentially, so you can think of it as sort of like the libc or PostGIS kind of layer for WebAssembly. And they said, okay, what if we run this inside of containerd so that we're not really running way up at the kubelet layer, we're running way down at the container runtime layer. And then we can shim in a lot of stuff there. There are fewer things we have to fake at that level compared to the kubelet level. And so they began doing a lot of work on RunWASI. In fact, they took Spin, they ported Spin over to run inside of RunWASI. So you can run a Spin application in Fermyon Cloud. You can run a Spin application in AKS on RunWASI. So Microsoft has continued to make a lot of progress there. Ultimately, though, at the end of the day, what that means is, well, all the people who are working on Krustlet have now said, it was a good idea and it works for what it does, but it is not the right path forward. So, we're in the process of kind of winding down the Krustlet project itself, which is in CNCF. RunWASI has now been donated to Containerd, which is, the big project governing all the Containerd runtime projects. So it really is, it's made its way into a foundation now. And again, it'll run spin inside of there. So we think that's really kind of the direction that Kubernetes integration will go. Still, I'm proud of the work we did on Krustlet, and we did some really great engineering. Learned a lot about Rust while we built Krustlet too. But at the end of the day, we had just chosen the wrong layer, right? We had picked the wrong abstraction layer, and that caused us more pain than it was worth. RunWASI, I think, a much better abstraction layer to just run down in Containerd. So I'm highly optimistic that RunWASI will be kind of the direction forward for Kubernetes at this point.
Okay. That's good to hear, because I don't think I've heard of RunWASI. I just feel like everybody went crazy for Krustlet, and then that was it. And I was like, okay, I gotta take a look at this at some point.
I think it got donated to Containerd like literally a few weeks ago. Okay. So I don't think it's not a big project like Krustlet was that has had time to gain a lot of GitHub stars. It's still a little under the radar.
I think the big thing was I think around that time, WebAssembly, I think, was in that middle graph where people were going oh, this is, going to be the next thing. And, there was books coming out about running on the edge, and I think that was kind of a very small kind of fad where it's oh, no, we're moving to the edge. So I think that's kind of where it kind of came out of. And then now it's nobody's talking about edge. Maybe I'm not in that crowd, but I haven't heard anybody talk about edge computing in a while. There was some talk for a while, and people were saying, and Cloudflare, I think, was talking about it quite a lot, but I felt like nobody was listening. I think everybody was shouting, but nobody was listening, or people just stopped listening after a while. I don't know what you see, because you're more in the space than me, but that was kind of my perception. And now nobody talks about edge, and now it's just well, let's just keep everything running with Kubernetes. And is there anything hot right now? I can't think of anything that's kind of people are talking about at the moment.
I mean, my feeling about edge is that once again, we had a term that was overutilized and underdefined, much like cloud probably was early in its life, right? And I think there's still some really interesting stuff kind of going on in the space. But we learned a couple of big things from edge, which I think are really kind of rippling out to other areas now. One of which is, being lighter weight and faster is actually virtuous wherever you do it, right? And I think we had gotten into this pattern of way over consuming on cloud services, right? We just ran way more instances of things than we needed. We bought bigger instance sizes than we needed. We kept data that we didn't need. And then we paid for all of that, right? As we're renting other people's disks and we're paying for disk space we're not using. And I think Edge really kind of retuned people to the idea that, maybe small is a desirable feature. And while there were elaborate stories, right, about, near edge, far edge, mid edge and stuff like that. And is it running right next to is it running in the cell tower? Is it running in your house? Is it running in somebody else's data center somewhere that's closer to your home than Amazon's? And it got very complicated and convoluted, and no two people knew quite what the other was talking about. But the similarity that kind of threaded its way through all of those use cases was that we were talking about smaller footprint installations, right? We were talking about running K3s instead of Kubernetes because we needed something that was a little smaller and could run in a more constrained footprint. That, I think, was a really useful discussion. And WebAssembly was part of that discussion. I wouldn't deny the fact that Edge's sudden rise to fame helped WebAssembly quite a bit, because a lot of WebAssembly's value proposition is smaller, lighter, faster, right? And I think, smaller binary sizes, lighter resource consumption, and faster execution times all are part of that kind of Edge story. Now, Fermyon's far more interested right now in the main cloud story, because we still think there's a lot of room to be done there. But, if that's what came out of Edge, I think that was successful. Whether the buzzword endures on to 2023, I don't know. But we learned some useful things.
I think no matter what, if somebody's looking for a way to stick into a job, maybe just work at an ISP, because no matter what, you have to go through a network to get because it's hard to stay up to date. Okay, should I be in Edge? Should I be in data science? Data science is still pretty hot, but I think that's starting to die down a bit. I think now we're starting to collect more data, so it's not going to go down to nothing, in comparison to what I hear about edge computing. But it's no matter what, people need to send data, whether it's a lot or a little. That's the only way to really stay in there. So maybe get a job in telecom or something if you want to keep it.
I wish you'd told me this 30 years ago. Would have saved me a lot of job transfers.
But your history is what definitely gives you the experience to work on these kind of things you're doing right now, right? At least that's the way I feel.
Yeah, I think so.
Because it's like, because you worked with cloud and you said, okay, VM's a little bit slow. Sure, they work, but they're slow. Okay, containers definitely helps with something, but
yeah,
they both have their negatives, and you want to find the positives of each and have that. And that's where WebAssembly kind of came in for you, at least, right?
Yeah. I do think, even like as you're pointing out, right, even being really enthusiastic about a solution and then discovering its limitations naturally, and then finding the next thing and being really enthusiastic about containers and then finding its limitations, and then finding another thing, WebAssembly, I think there's a lot to be gained from that early enthusiasm. And then a lot of wisdom happens when you go, okay, this isn't going to solve all the world's problems, but it is going to do X really well, right? And then you start to understand how to fit things together. And instead of getting caught on the kind of hype cycle, you start looking at things as one great big architectural problem to solve. And how do we fit these pieces together to make the right thing without making it so complicated that nobody can use it?
Oh yeah, that's definitely it. Now I kind of want to define what Fermyon does more clearly, right? So because you worked on spin, you worked on these different things, but those are, if I understand correctly, based on what I understand on Fermyon website, is that those seem kind of like ways to get people onto the platform. And Fermyon's really all about running your WebAssembly applications on the cloud. That's what I understand. Is that the correct way to say what you guys are doing?
Yeah.
Okay.
And I think one of these kind of core intuitions we had at Microsoft, core insights we were at Microsoft during the kind of first wave of serverless computing, when Lambda really got going and Azure Functions started, and OpenFaaS got off the ground. And we heard the same thing from developer after developer, which was, these are really cool technology. I really like the fact that I only have to, I can start with an HTTP handler and immediately dive right into what I care about, which is putting an item in the shopping cart and returning it back to the, whatever, the processing an image or doing a big data transformation or whatever, and then returning and exiting, instead of having to build up an entire server and manage the routing table and manage the process ID or the process lifetime and all of that kind of thing. So we'd hear developers, singing the praises of functions as a service and then going, and the but was always the same. I don't like vendor lock-in. They're hard to debug. They're hard to deploy. It's kind of hard to build because I have to use a bunch of... Okay, well, what we're hearing loud and clear from developers is that there's a particular way of developing that they like, and they feel like nobody's doing it terribly well. So all we have to do is get a little bit better than the way it was before, and we can give developers something they'll actually really love. So all along, we've been kind of trying to build that functions as a service style programming model, right? Where you're really just, you start with a function, you do the thing you care about, you return, and in practice, it executes like, request comes in, you start it up, you execute the function, you shut it back down and tear everything down. And that model works really well for WebAssembly, because WebAssembly is excellent at starting up really fast and using only moderate resources. So we went, all right, well, here's a compute style that matches the actual thing that people have been trying to build for the last 5 years, but have been building it on a technology that isn't sort of the right technology. And so we've been able to, so for example, a Lambda function may take a couple hundred milliseconds or more to get to the first instruction, to be able to start running your program. The Fermyon's platform, because we're using WebAssembly, it can get to the user's first instruction in under a millisecond. So it's, 200 times fast. It's a 1/200th of the overhead that you get with a Lambda function. And that's just because we're not running in a mode where we have to deploy a virtual machine and drop the workload on it last second and wire it up to networking. WebAssembly runtime that only consumes a few meg of memory and has the application, ready at hand and can instantly start it up and shut it down and run in this kind of nice, secure multi-tenant mode like we were talking about with the browsers. So that's really where we've gone with it. We said, okay, we see an opportunity here to build a better, serverless V2 kind of platform that has a lot of the things that developers love, but not necessarily a lot of the frustrations. So that's where we're really going with that.
Yeah, I was starting to think like, oh, what's the difference between this and Lambda? Because that's what Lambda is all about. But less than a millisecond is huge, right? 400 milliseconds. Yeah. Because that was really starting to come to my mind. Like, it sounds like this. And even that there's a term function as a service.
Yeah.
That's interesting. And also you can, I mean, if you can, because you're working on the cloud, right? It's different than, let's say, if I could spin this somehow into my own internal cluster that I'm running, but this is more on the cloud. And the way you guys are running, do you have data centers around the world so that I could say distribute this to the different backbones and everything?
I mean, right now we're running it inside of AWS. We will invest at some point in our own data centers, but as a small, scrappy startup, we're like, well, we can run this on top of we just need raw virtual machines and networking, right? And so we're running in AWS, basically offering a layer on top of it. And that has worked out really well for us. And then, of course, we get all the regions and data centers that they already have.
Okay. That's the annoying thing about that, when you had to go through and enable all these Randoc things. I know I'm in Hong Kong, and so I was surprised that, like, even though I'm in Hong Kong, I have to go through and I have to enable Hong Kong, and it's like, do you really want to do this? Yeah, I want to do that. I thought that was very weird that they like warn
Are you sure you know what you're doing? Yeah, I'm sure. Just turn it on for me, okay?
It starts to make you wonder, am I getting billed for regions if I just turn them on? I don't know why it needs to ask you if you need to enable a region, if it's okay or something. It's really weird.
I've never looked into why. I imagine it's a litany of things, from like how much you're going to get charged when you do use resources to some kind of legal ramifications that I don't understand.
That could be part of it. But I think the main thing is, like, you know how you always have this, what is it called?
Like a funnel?
No, like, a tenant-based look at your whole account, right? I'm looking at North Virginia, right? I can't see anything in Singapore, something like that.
Yeah.
And I don't know how they always put me in Virginia all the time. Every time I log in, it always puts me in Virginia. I don't know what, maybe because I have something running over there.
These are things I do not understand. If you ever figure them out, let me know. I think it would go to closest to you geographically or whatever, but yeah.
There's no Amazon guru out there who knows everything about Amazon, except for the people on support. And they seem to just know which web link I should be looking at. That's all I get. Read this 5 pages over here. Oh, damn. Every time it's like that.
One of the things I learned, inside of Azure was that quite literally, you're right. You add a catalog of products that's that big, and each one of those takes a team of between 10 and several hundred people to operate it. You get to the point where it's impossible for any one person to know even more than beyond the basics of all the different platforms. And in a way, that's sort of like the testament to why cloud is pretty awesome, right? That you can have these highly sophisticated services and really be able to use them without gaining that level of expertise. But on the other hand, I mean, every dashboard for every cloud sort of feels like a wall of services, of which I know maybe 1/12 of them. I have no idea what all these things do, and nor do I have the time to learn.
Well, the other thing too is, like, for some services, they're not available in all regions. So you're like, I don't know if I chose the right region.
Yep.
And all this other stuff, that's really annoying. But I understand that, like, they can't be available everywhere, but it's just like, you would like to know as soon as possible, right? Because imagine if you select the wrong region. From what I remember, I think Singapore has probably got always the latest stuff, but I'm in Hong Kong, so it's like, well, which one should I choose? And this kind of thing always comes to my mind.
Yeah, I remember we would roll things out to regions, very specifically, one at a time, make sure it was there, make sure that customer workloads got up before rolling it out to the next one. And it's got pros and cons, right? The pro is, you kind of find out soon if your thing's going to tip over. But the con is, user frustration is a very real thing, right? And it was frustrating to be like, okay, well, this is going to be available in Europe next month, but don't worry, it'll be available in Australia next week. As if somehow that solves the problem I feel the frustration there.
I don't want to talk about that. Let me just, no, forget it. Actually, I do want to talk about this. I love Google and stuff, but the GCP, I think the UI is actually less confusing than AWS, but maybe that's just me. When they just launched in Hong Kong, I think 3-4 years ago, something like that. And I tried to launch a Kubernetes cluster and it just failed every single time. And so I got a hold of their support. I said, this is failing. And then they said, yeah, we know. I said, what do you mean you know? You're going to fix it, right? They're like, yeah, we're working on it. Do you have an ETA? Nope, we don't have an ETA. Okay, so what do? Can I subscribe to a mailing list or something so I know when it's fixed? No. You just keep trying until it works, and then when it works, then we fixed it. What? That was their reply, really. I don't know if those exact words, but that was the reply.
Right.
I was like, this is ridiculous. I don't want to use this.
Yeah.
But actually, I used it because I had free credits. But yeah.
Well, and a lot of this goes back to the conversation we were having a little while ago, right? Is that, there's a lot of complexity going on. But at the same time, you got to pay attention to the people who are using it, right? The user interface has got to be really well tuned. And the way you deal with anything from an outage to, the developer's first experience trying to deploy an application has got to be very well streamlined, because you lose people along the way. If you can't help them understand, yes, we understand your system is down. It'll be down for a while. We've got a window of X amount of time, and then this light will go green on your dashboard when it's all back up. That kind of thing is great for a user, because at least then they know what's going on. Even if they're frustrated that it's down, at least they know when it'll come back up, or at least what it looks like when it's back up. And that would probably save a number of people from going, all right, well, if this is my experience, I don't know when it's coming back. I'm just supposed to keep trying like I have nothing better to do. I'm going to go away, right? I'm going to go try another service. And I think user experience is a really important part of anything we're building from here on forward. And if we're going to keep building a litany of all kinds of different web services, we're going to have to get really good at making it very clear to anybody what's going on at any given moment and how to get from current state A to desired state B.
I just want to kind of get back to the cloud offering you guys have before we need to exit off. So obviously go to fermyon.com. There's a huge blog talking about spin, etc., how to use everything. Mm-hmm. I'm guessing that if you want to, there's also Get Started, everything like that. So people should come check it out. Do I have to use Spin to get my application on here, or can I use any kind of like WebAssembly framework, etc., language, all that?
That's an interesting question. Essentially, as long as you can compile your source language to WebAssembly with the WASI extensions, WebAssembly System Interface extensions, you can build applications that basically function like CGI applications from the days of yore, right? Where you're really just using environment variables and inputs, standard IO and standard error. If you want to really take advantage of deeper API level integrations, you probably want to use Spin for the SDK. But for the most part, most of Spin is just, an ease of use tool to make it easier to start something, easier to build it. And then you ultimately will need it to deploy it to Fermyon Cloud, because that's the thing that authenticates and pushes the code up. But you could use all your other tools for everything else and then just use Spin deploy to push it up into our service. And that would be totally cool. I'm still with Rust's got, it's got a target WASM32 WASI compile target. I usually just use the Rust toolchain to build most of my stuff and then just use Spin to deploy it, because I love the Rust toolchain. I'm really used to the Rust toolchain. When it comes to C or something like that, where I'm like, I'm not messing around with all these compiler flags, I'll use Spin build and it'll use the right tools. Fun fact, the C Spin tools, we actually use the Zig toolchain, because the Zig toolchain is better at compiling C than most of the C tools we could find. But, it's that kind of thing. Largely, it's what we would call a developer ergonomic tool, right? Something to make it easier for the developer to build. But WebAssembly with WASI is what it requires to be able to execute these things on the Fermyon Cloud. And those are WebAssembly and WASI are both W3 standards. So there's no magic going on there or anything weird. If you want full SDK support, though, we've got Spin libraries for Rust and Go and Java and .NET and a number of other languages.
Awesome. Well, I thanks for taking us to the whole history of how you got through all this stuff. Your background is really quite impressive, and I'm happy that we got you on the show. I'm surprised I just didn't know who you were, just reach out directly at this point. But I'm happy that we're too bad programmers aren't like rock star movie celebrities where we know everybody in the community. But it's interesting to hear the history of all these things come from.
Actually, I kind of prefer the low profile. Yeah, well, thanks for having me on. This was a lot of fun to talk about. And as you can tell, I get a little excited and go for a long time, but it's a lot of fun.
You prefer low profile, but you do have your own publicist. So I don't know. I mean, you're kind of teetering over here.
Technically, it's the company that does that.
Oh, okay, there we go.
It's the cost of it. It's how you do business.
Yeah, you put the buffer in between, so
that's right.
Good.
Yeah,
yeah. Now you're a real CEO. You got to put something in between, so that way you have plausible deniability, right?
I like it. Yes.
Yeah, that's the way to do it.
Yep.
Awesome. Again, thanks for your time on here. And I'm looking forward to this episode coming out. I'd like to hear the feedback from the audience.
Yep, me too. Thanks a lot.